Okay, so we're going to go ahead and start with the next topic, which is matched pair t-test for means. This is kind of a combination of both the comparing to means, so the difference of means that we did in the previous topic, and a one sample t-test. It's a combination of the two, and you'll see why in a bit. Okay, what we're going to be working with in this particular topic is going to be paired data. Okay, and with paired data, we basically have the following. We have data that's coming from, or that comes from, one individual. Oops, I don't know why I hyphenated that. Okay, one individual. Okay, and I'm going to underline that because it's either coming from one individual or from a pair of similar individuals. Okay, and what I want you to kind of think about is that activity we did with the chocolate chips. Remember when I had you go up and try two types of chocolate chips, and then I asked for your opinion on both? That's kind of what this is, or what I mean by paired data. Okay, so I want you to think of the chocolate chip activity. So what you'll see is you'll either see a scenario where you're collecting data from one person under two different circumstances, or you're collecting similar data from two different people whose characteristics are kind of alike. All right. Now, what we're going to want to know in this particular topic is going to be the mean difference. So we want information about the mean difference. Okay, so in the previous topic, it was kind of the difference of the means, and this one we want the mean difference. All right, so let's go ahead and talk about some notation really quick that we'll be seeing in this particular topic. Okay, since we want the mean difference, we're going to annotate things a little bit differently. For example, your sample mean is going to have a subscript, and they're all going to have the subscript of diff. Okay, you can also do mu or x bar sub d. We're just going to use diff for difference. Okay, and then of course you have your sample standard deviation of the difference. Okay, and then your sample size for the difference. Okay, and then of course your population parameters, mu, population mean, or the mean difference, the true mean difference, the true standard deviation of the difference, and then of course the population size for the difference. Okay, all right. So one of the things that we're going to have to do in this particular for confidence intervals and for means, hypothesis test, is we first have to, that's not a surprise, to compute the difference for data, or for the data. Now, there is some cases where the difference is going to be given to you, so they'll tell you the sample mean difference, or the sample mean difference, the sample standard deviation difference, or the sample size difference. But there's other times where you're going to be getting data and you have to actually compute the difference, and I'm going to show you how to do that on the calculator as well. Okay, so let's go ahead and look at the conditions. Conditions, for confidence intervals and for the t-test. Remember, since we're working with means, we're of course going to be doing a t-test. All right, and in this one, conditions are very similar to what we've already worked with. Okay, even though you're working with two populations, you don't have to establish these conditions for both. You're just going to establish them for the difference of that you're working with. Okay, so for example, the first one is of course your random sample, or you should also or you could potentially also have random assignment. Okay, the next one is the sample size for the difference has to be less than 10% of the population size for the difference. Okay, the third one is that the population distribution of differences is normal. Okay, so if it says that the population distribution of differences is normal, so that that would satisfy the third condition. Or, okay, of course, if you have that your sample size for the difference is greater than or equal to 30, you can apply the central limit theorem. Now, just a quick note, I was grading your exams, and some of y'all like to use the central limit theorem as a condition for a z-test for proportions. Remember that the central limit theorem is specifically for the tests or confidence intervals in which you have means. Okay, and the last potential way you can show normality is by showing the graph or assessing sample data. That's basically what this step is. Okay, but showing the graph of the sample difference data. Okay, and I'll show you what I mean in a bit, and ensuring that there is no strong skewness or outliers. That there is no strong skewness or outliers. Okay. All right, so those are going to be the conditions that we're going to be working with for both the confidence intervals and the t-test. Okay, and the last thing that I'm going to make a note of before I jump into examples is going to be how we run our hypothesis test. Okay, so for a hypothesis test, in terms of writing your null and your alternative hypothesis. Okay, by the way, if it's a confidence interval, you don't need a null or your hypothesis, your null hypothesis or alternative hypothesis. That's only for a hypothesis test, and when the question asks you for convincing evidence, that's usually what they mean. Okay, another big indicator of you having to conduct a hypothesis test, if it says a significance level, then you're going to go ahead and go with that. Okay, so in this particular case, whenever we write our null hypothesis, you're going to state your population parameter, which if you paid attention to notation, is just going to be this one right here, the mean difference. Okay, so mean difference. Okay, and typically for the null hypothesis, we have this mean difference be equal to 0. Okay, for the alternative hypothesis, of course, the population parameter has to be the same. Okay, the number that you use has to be the same, all right, which is 0. So you'll either have less than, greater than, or not equal to. All right, those are the signs that you're going to end up having for when you state your null and your alternative hypothesis in this particular hypothesis test. All right, now let's go ahead and jump into some examples. Do example 1, and this one's going to be for confidence intervals. Again, your examples are here on Google Classroom, so feel free to look them up. Okay, so for the first one, it says a researcher studied a random sample of identical twins who had been separated and adopted at birth. In each case, one twin, twin A, was adopted by a high-income family, and the other, twin B, was adopted by a low-income family. Both twins were given an IQ test as adults. The data of the random sample of identical twins are shown in the following table. We want to construct and interpret a 95% confidence interval for the true mean difference in IQ scores among twins raised in high-income and low-income households. Okay, so I didn't write down the procedure, but the procedure is going to be exactly the same as what it's always been. The first thing we want to go ahead and do is we want to go ahead and state our population parameters, right? And exactly what the mean difference is going to end up being. So in this particular case, all right, we can go ahead and state the following, okay? We are just going to state the mean difference because that's technically our population parameter, right? So the mean difference is going to end up being, and it actually states it in the problem, right? You're going to use the same notation all the time for a matched pair t-test. You're going to have mu sub diff, okay, and here it's going to tell you exactly what it is. All right, so it's going to be the true mean difference in IQ scores among twins okay. Now, for the twins, let me just make a note. Well, I'll make the note at the end. Okay, among twins raised in high income and low income households. Okay, so I'm going to make a note as to which value I'm taking first and which value I'm taking second. So I'm going to do high income. That doesn't need to be hyphenated. High income minus low income. That's the difference I'm going to take in this case. Okay, and typically the problem will tell you what kind of difference you want to take. All right, so that's the first step. We defined our population parameter. Okay, the second step is to, of course, go ahead and list your conditions. All right, the first one, okay, is random sample. Here we have a random sample of identical twins. So we have that condition met. So random sample of 12 pairs of identical twins. All right, that's the first one. The second condition is, of course, a 10% condition. Your sample size is 12 here. Okay, so 12, we're going to go ahead and assume, okay, there are more than 120 pairs of identical twins. I misspelled identical, where did it go? Identical. Okay, now be very specific here. Identical twins where one is raised in a high income household and the other in a low income household. And this what household then. Household. All right, there we go. So that's our 10% condition. So random sample, 10% condition. And then the last one, of course, is to go ahead and create a dot plot or a histogram or a box plot. We've been sticking to a box plot just because it's easier. Okay, and make sure that there is no extreme skewness or outliers. And if there is, of course, we proceed with caution because we want to go ahead and carry out the procedure. All right, so what we're going to do, since we have the data already here, we're going to go ahead and put it in a calculator page, and it should just scoot it over. Okay, so here I already typed it in. So in this first column, I have the IQ of twin A, and the second column, I have the IQ of twin B. And so here's where things are going to differ a little bit. I want you to go to the third column, and I want you to type in difference. Okay, or you can type in diff. Okay, whichever. So the difference, and in this next little bar, you're going to go ahead and type in a formula. Okay, you're going to click on equals. So we're going to define a formula for the difference. Okay, and the difference, just the way we defined it in step one, we're going to take the high income minus the low income. So the high income was twin A, so we're just going to click on bar and go to the twin A IQ, and we're going to subtract because we're taking the difference. Okay, twin B, right? And it should give us the difference of the first two columns, right? And this sample data is what we're going to be using to conduct our hypothesis test, this different value, okay? We're not going to worry about the individual IQs of twin A or twin B. We're going to look at the difference between the two IQs, okay? So we're going to go ahead and check our sample data, okay? Go to data and statistics, and when we click to add a variable, we're going to look at the difference, right? And there's our dot plot, but I'm going to go ahead and do a box plot just because it's easier, okay? And here you go, here's our box plot. As you can see, there's no extreme outliers, there's no extreme skewness, so we're going to go ahead and draw this dot plot on our paper and go ahead and write that there is no extreme skewness or outliers, okay? And I'm just, for the sake of time, I'm just going to go ahead and draw a box plot, a general box plot. That looks kind of like what you have. Of course, you already know you should be doing your labels, so there's going to be difference. Okay, you should tell me your numbers, exactly how they appear, not the way I'm doing it. This one's going to be 6, 8.5. You're going to basically copy down the box plot as it appears. Okay, same scale and everything. I'm just going quickly through this. What was the minimum? The minimum is -1. Okay, so there's our dot plot, and we're just going to make note there is no extreme outliers or skewness. Okay, so there we go. We have our 3 conditions. We can go ahead and go on to step 3. In step 3, we're going to go ahead and name the test or name the confidence interval that we're working with. In this particular case, we are going to be working with a t interval. So it's going to be a 95% confidence interval, right? And it's a one sample, or not, I'm sorry, it's not a one sample, it's a matched pair t-test. Okay, so whenever you're taking this difference, you're doing a matched pair t-test. Okay, and you're going to treat it, since you're only looking at one variable, essentially the difference, you're going to treat it as a one sample t-test. Okay, so when you conduct this test on your calculator, so go to a calculator page. Okay, oops, that's not a calculator page. Go to a calculator page and you go to menu, of course, statistics, and then confidence intervals. You see you have the 2 sample t interval, which is what we used the last time. Now, even though we do have 2 samples in a sense, we're only working with the difference of those 2 samples. So we essentially have just one value to work with, okay, or a list of one variable to work with. So go to t interval, okay, and we're inputting data. Okay, the list that we're going to be working with is the difference, not twin A or twin B. And we want a 95% confidence interval, so that's going to stay the same. We're going to click OK. All right, and we get our interval. Okay, the degrees of freedom are also important. Okay, and of course your sample mean, just because we didn't compute anything just yet. All right, so on our paper, we're going to go ahead and list these values. All right, so getting the matched pair t-test, we end up with an interval of 3.338, comma 8.32867. All right, and then we have our sample mean, okay, which is going to be 5 point, and I'm going to write difference, okay, 5.8333. Okay, we have our degrees of freedom. Okay, it's always important to note your degrees of freedom, and then your sample standard deviation, which is going to equal to 3.92737. Okay, so that's going to be the work part. Remember, that's step 3. And then step 4 is, of course, to interpret. Okay, so when we interpret the confidence interval, we just write I am, or we are, whichever you want. I am 95% confident that the true, and remember, this part is just what you wrote in part A, so that the true mean difference, okay, true mean difference in IQ scores among, I can just copy and paste, among twins raised in high income and low income. And then again, I'm going to want to reiterate how I did my subtraction. So it's going to be high income minus low income is between, and then you write your interval, 3.338 and 8.32867. And there we go. We conducted a confidence interval, 95% confidence interval for this particular problem. Okay, now let's go ahead and look at an example for hypothesis testing. This is example 2. All right, so for example 2, let's go ahead and look at where I have it and where I have it. There we go. All right, so for example 2, it says researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, the subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which the subjects took caffeine and the placebo was randomized. At the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. The table displays data on the subject's depression scores. Higher scores means more symptoms of depression. Okay, so there's our data, and we want to know whether there's convincing evidence at the 5% significance level. So the minute you see convincing evidence, you should start thinking, okay, I need to conduct a hypothesis test. Okay, if you see significance level, that's even a bigger indicator that you're doing a hypothesis test. That caffeine withdrawal increases depression score on average for subjects like the ones in this experiment. Now notice in this case, you have your subjects listed as 1, 2, 3, 4, all the way to 11. And from the subject, you're getting 2 different sample values, right? Their depression score when they had the caffeine pill, and then their depression score when they took the placebo. Because you have 2 values coming from the same person, okay, you're going to go ahead and do a matched pair t-test. Okay, so this one's going to be a matched pair t-test. All right, so in this particular example, again, we're going to start it off as we normally do. We have to go ahead and state our hypothesis, so your null hypothesis. Remember, your population characteristic of interest is going to be the mean difference, which is always going to be equal to 0. Okay, and then your alternative hypothesis in this case, again, mean difference is your population characteristic of interest and 0. And we're going to go ahead and make this greater than 0, right? So we also have to define what mu difference is going to be, all right? And this mu difference for this particular case is going to be the true mean difference okay, and I want the difference between the placebo and the caffeine. And the reason we're going to go ahead and see if I can do it before my iPad dies. Okay, the reason that I chose placebo and caffeine is just because if you notice the values, the placebo one is higher, is bigger than the caffeine one, so I don't want negative values if I take caffeine minus placebo, so we're just going to go ahead and do that. Okay, placebo minus caffeine for the positive values. Okay, the true mean difference in depression test score for subjects like these. Okay, so there's our step 1. Step 2 is of course going to be our conditions. All right, now the first one is going to be randomness. Notice they don't really talk about randomly selecting individuals, but they do talk about randomly assigning the pills to each individual or what they're going to be taking. Okay, whether it's going to be the caffeine or the placebo. So what we're going to go ahead and write for the first one is going to be random assignment of treatment. Okay, so we have the random assignment of treatment, that's the first one. Okay, the second one is going to be the 10% condition. Okay, so here we have a total of 11 subjects, okay, with caffeine addiction. All right, so we can just say we assume there are more than 110 individuals with caffeine addiction in the population. Okay, and then the third one is of course determining whether your distribution is normal. In this case, the problem doesn't say that it's a normal distribution. Okay, we can't apply the CLT because our sample size is less than 30. So that means we have to go back to our sample data. So I already typed in all of our sample data over here. Okay, I have caffeine and placebo. Remember that we're not interested in just the caffeine and the placebo separately. We're interested in the difference. So again, we're going to go ahead and type in difference. Okay, and in the formula bar, you're just going to type in equals, click the bar, and we said we were doing placebo minus caffeine, so I'm going to type in the placebo first, minus, okay, caffeine, and there we go. It gave us our differences, and they're all positive, okay, for the most part. All right, and now after that, we can go ahead and look at data and statistics. Okay, and we're just going to go ahead and click on the difference because that's what we want. And of course, I'm going to go ahead and create a box plot. And there we go. And I'm just going to write box plot goes here. I'm trying to beat my battery. Okay, box plot goes here. All right, so here's our box plot. As you see, there's no extreme outliers, no extreme skewness. So on our paper, okay, after we draw our beautiful box plot, we're going to write there appears to be no extreme outliers or skewness. Okay, so there we go. We have our three conditions. Okay, now the third step is of course to do the work. So this is going to be a matched pair t-test. Okay, matched pair t-test. So for the matched pair t-test, okay, we're gonna do it similarly to how we did the confidence interval. Okay, remember that for the confidence interval in the previous example, we took a one sample t-interval. Okay, so in this case, we're gonna conduct it as if it were a one sample t-test. Okay, so on a calculator page, menu, statistics, and then stats test, you're going to treat it as a t-test. Okay, in this case, again, we have data, and oops. Okay, so our mean, our mu naught is going to be equal to 0. Okay, the list that we're going to be working with is, of course, difference. Okay, and the difference that we're working with is that it's going to be greater than 0. Right? Greater than 0. There we go. And we have all of our values. Okay, so now we can go ahead and write down our information on our paper. Remember, it's very important that you list your test. So we have a matched pair t-test. Okay, and we're just going to list the t-value. In this case, your t-value is going to be 3.53043. All right, and then your p-value is going to equal to 0.002721. Okay. And then your degrees of freedom is going to equal to 10. Your sample mean is going to be 7.37364. Oh wait, 36364. My bad. 36364. And then of course for the difference, sorry. And then the sample standard deviation of the difference is going to be equal to 6.9177. Okay, so those are going to be the values that you're going to go ahead and be working with. Okay, so now we can go ahead and write our conclusion. Now, just so you know, this is going to be on a t-distribution, okay, with degrees of freedom equal to 11. All right, and what we calculated is, of course, a t-value of 3.3504. So your 3 standard deviations above the mean, which is 0. Okay, 3.53043. And you calculated this particular area, okay, this p-value, which is going to be 0.002721. Okay, so we're going to compare it to the significance level alpha, which was going to be 0.05, and we see that the p-value is less than 0.05, which is equal to alpha. So remember, if the p-value is low, you reject the whole, okay, the null hypothesis. Okay, so we're going to write that down. Since your p-value is equal to 0.02721 is less than 0.05, which is your alpha, we reject your null hypothesis. Okay, and then we can just go ahead and restate the question that was stated in the problem. Okay, so in this particular case, why isn't it moving? Okay, in this particular case, we can just go ahead and write the following. Let me see. There is convincing evidence, okay, that, I'm trying to see what the rest of it says, that caffeine withdrawal increases depression score on average for subjects like the ones in this experiment. And there we go. We have all four parts to the hypothesis test. Okay, keep in mind that there is four parts to the hypothesis test and the confidence interval, so you have to make sure that you do all of them.